Okay, good morning, my dear students. Uh, Today we are.
Good morning, sir.
Good morning, very good morning. Today we are.
Good morning, sir.
Good morning. So I welcome all of you to the chemistry class for 9th standard. And today we are going to discuss the various topics. These topics that we are going to discuss today are the size of the atom. So, even in the last period, we have studied about the size of the atoms. Today, we are going to revise it and understand it once again. And we will see the various symbols and names for the elements. So let us start our class. Let us pay attention to the, or आप लोग सब, you even all of you, please pay attention to the various or the screen that I have shared with you. So please pay attention. And yesterday we have seen about the Dalton's atomic theory. So let me give you a gist or of the Dalton's atomic theory. According to the Dalton's atomic theory, all matter is made up of teeny particles, and these teeny particles are known as the these teeny particles are known as the atoms. Atoms are indivisible particle which cannot be created or destroyed in a chemical reaction, and this is actually representing the law of conservation of mass. Then we have the third one, atoms of a given element are identical in mass and chemical properties. Then we have the fourth point, atoms of different elements have different mass and different chemical properties. अगर आपसे गलती से कोई ऐसी लाइन बन जाती है तो उसको रिमूव कर दीजिए, ये मुझे डिस्टर्ब करती है आपको पढ़ाने में. तो ये लाइन अगर आप लोग रिमूव कर सकते हैं किसी तरह से तो प्लीज इसको रिमूव कीजिए, क्योंकि ये मुझे पढ़ाने में डिस्टर्ब करेंगी. अगर आप किसी तरह से इस लाइन को रिमूव कर सकते हैं तो कर लीजिए, जिसने ये लाइन बनाई है. नेक्स्ट टॉपिक दैट वी हैव इज द टॉपिक वेयर वी स्टडी अबाउट द एटम्स कंबाइन इन अ रेशियो of small whole number to form compounds. And then we have the next topic, or the sixth point of Dalton's atomic theory. The relative number and kinds of atoms are constant in a given compound. This actually represents the law of constant proportion. So the sixth point represents the law of constant proportion. So this law of conservation of mass says that mass can never be produced or destroyed in a chemical reaction. And law of constant proportion says that when a compound is formed, this compound has a certain or a fixed ratio of the elements, either by the mass or by the number of atoms. Then, my dear students, we have studied about the atom. So we have seen that atoms are the building blocks of matter. How big are the atoms? So we concluded that atoms are very small. We cannot see them. We cannot see atoms with the naked eye. So they are so small. To measure the volume of an atom, we use the unit. This unit is known as the nanometer. You can see here, this unit is known as the nanometer. The unit by which we measure the size of an atom is 1 meter divided by 90 after 1. So such a big or such a small meter, such a small part of meter is your nanometer. And this is how, my dear students, we understand the significance of nanometer. We come to know that the atom is very small by understanding that the atom of hydrogen has got the radius of 10 to the power minus 10 meter. The molecule of water has the radius of 10 to the power minus 9 meter. 9 meter, or the radius of the hemoglobin is 10 to the power minus 8 meter. The radius of the grain of the sand is 10 to the power minus 4 meter. The radius or the size of an ant is 10 to the power minus 2 meter. And the radius of the watermelon is 10 to the power minus 1 meter. That is 10th part of a meter. And that is how, by comparing this, we can conclude that atom is very small. So if atoms are so small or so, insignificant, atoms are so small, and if they are so insignificant in size, why should we care about them? This is even an important point, my dear students. That if these atoms are absolutely insignificant, if these atoms are not significant, they are very small, why should we study about them? Why should we care about these atoms? The answer is quite simple. Let us try to understand it. Atoms are very small, but we care about them. We study about them. We study them because our entire world is made up of atoms. Please remember that entire world, entire universe is made up of atoms. We may not be able to see them, but they are there, they are always there, and they constantly affect whatever we do. So the simple idea, why do we need to study these atoms? We need to study these atoms because everything is made up of atoms, and the atoms, they exist around us. We cannot see them, but they affect our life. They affect each and every action. They affect everything that we have all around. And that is why it is important to study. It is significant to study the atoms. Next question. Atoms are very small. How do we study them? When these atoms are very small, we cannot see them with our naked eye. Then how do we study them? How do we study these atoms? Let us understand. Atoms are very small. We cannot see them with the naked eye, but using the modern techniques. We have developed some technologies, we have developed some techniques that using these modern techniques. What is this modern techniques? This modern technique has produced electron microscope. The modern technique has produced electron microscope, my dear students. This electron microscope is the device. Remember, my dear students, that electron microscope is the device that can even see the electron. Electron is very small in size, and this electron microscope even can see the electron. So, my dear students, this electron microscope is useful for studying the atoms. So, what is this electron microscope? Let us try to see this electron microscope. This electron microscope, you can even note down, my dear students, if you wish to note down, that electron microscope, it is a device that make small thing visible to us. Even the atoms. So my dear students, this electron microscope is the device. Using this device, we can see atoms, and as we can see atoms, we can study them. How do we develop electron microscope? So electron microscope is developed using modern techniques. So this is how, my dear students, we truly understand about the electron microscope, and we really understand. So now we can understand this question, and we can understand this answer, that atoms are very small. How do we study them? So atoms are very small, but we cannot see them with the naked eye, but using the modern techniques. So modern techniques actually develop the electron microscope, and using this electron microscope, my dear students, we can see atoms, we can study atoms, and we can produce their magnified images. We can produce their magnified images. What is the meaning of magnified? Magnified means, or magnified images means, images or big images. Images images bigger in size. So we can have the various images which are bigger in size produced by the electron microscope, and we can easily study this electron microscope. We can easily study the atoms using the electron microscope. Next question that we have, name the scientist who first used the symbol of atoms. Show symbols of elements as proposed by a scientist named Dalton. So remember, my dear students, that Dalton was the first scientist to use symbols for the elements or symbols for the atoms. He represented the atom of the various elements with the various symbols. You can see here we have a table, and here in this table, my dear students, we can see the various symbols for various elements. The symbols for the various elements are there on your screen. So you can see the symbols on your screen, my dear students. Please have a look to the various symbols on your screen. बच्चों, क्या आपको आपकी स्क्रीन पे ये सिंबल्स दिख रहे हैं?
Yes, sir.
Yes, sir.
और दिख रहे हैं?
Yes, sir.
Yes, sir.
Wonderful, wonderful.
Yes, sir.
Okay, so let's have a look to these various symbols that we are going to study. Let's have a look to this.
Yes, sir.
You can see the first symbol of hydrogen. This is the symbol of hydrogen, where you have a circle and a dot in between. Then you can study the symbol of phosphorus. Please note down these symbols, my dear students. They are going to be very useful. Then, my dear students, we have the symbol of copper, where in the circle we write C. Then we have the symbol of gold, where in the circle we make the triangles along the circle, and then we write G in between. Same way, my dear students, we are going to study a few more symbols. This is the symbol for platina or platinum. Platinum is the element, my dear students. So this is the symbols for the element platinum. Then, my dear students, then we have the symbol for lead. This lead is used in pencil. So you make a circle and just write L. This is the symbol proposed by Dalton for lead. You draw a circle. You simply draw a circle this way, and then you draw, cross mark into this circle. You simply draw this cross mark into this circle, and when you draw the cross mark here, this way, then this is the symbol for your sulfur. Then we have the other symbol. This is the symbol for carbon, where you simply draw a circle and shed the inside region. Then we have the other symbols. For oxygen, we have just a circle. For oxygen, we have just a circle as a symbol proposed by Dalton. For iron, we have a circle and I inside that. For silver, we have a circle and S inside that. And for mercury, we have the circle and a very small filled circle inside the circle along its circle, and that is what it is known as the symbol for mercury. So, my dear students, please learn the symbols which are proposed by Dalton. Please learn the symbols which are proposed by Dalton. So Dalton was the first scientist to propose the various symbols for atoms of element. Or we can say that Dalton's represented the atoms of various elements with a particular symbol. Then we have the next point to study. Which scientist suggested that symbol of element be made from one or two letters of the name of the element? There was a scientist, his name was Berzelius. There was a scientist, his name was Berzelius. So Berzelius suggested that the symbol of element be made from one or two letters of the name of the element. So this was suggested by a scientist Berzelius. How did the name of elements were derived in the beginning? Give example. So let us study in the beginning how the names of the various elements derived. In the beginning, my dear students, the names of the element were derived from the place. The name of the element were derived from the place from where they are found for the first time. For example, name copper, please remember, for example, name copper was taken from the Cyprus. From this, because copper was first found in Cyprus, and that is why the name copper for Cyprus is given. How the name gold was given to the element. How the name gold was given to the element. Name gold was taken from its specific color. See, the name copper was taken from the place from which it is taken, but the name gold was taken from the color of the metal or color of the element. The word gold was taken from the English word meaning yellow. Next, nowadays, name the organization that approves the name of the elements. So, you know, various scientists, my dear students, they give name to the various elements, they give symbols to the various elements, and these symbols they have to present in front of a particular organization. In front of a particular organization. This organization approves whether the given name is allowed or not. So we need to understand the name of this organization. Nowadays, IUPAC, this is the name of the organization, IUPAC approves the name of the element. The full form of IUPAC, I stands for International, U stands for Union, P stands for Pure, A stands for Applied. Please remember, A stands for Applied, and C stands for Chemistry. So what is the full form of IUPAC? If someone asks you, my dear students, what is the full form of IUPAC? If someone asks you, you can easily say that IUPAC means International Union of Pure and Applied Chemistry. So my dear students, what is the full form of IUPAC? Can you tell me, all of you? बच्चों, अगर आपसे पूछा जाए तो क्या आप बता सकते हैं व्हाट इज द फुल फॉर्म ऑफ IUPAC? प्लीज बताइए डियर स्टूडेंट्स,
In
व्हाट इज द फुल फॉर्म ऑफ
International Union of Pure
IUPAC?
Applied Chemistry.
वेरी गुड. So what is I stands for?
International
U stands for,
Union
P stands for,
Pure
Pure.
A stands for,
Apply
Apply.
and C stands for.
Chemistry.
Chemistry.
So let us all of us write. You also write in your notebook that I stands for International. I stands for International. U stands for Union. Then we write off. P stands for pure. Then we write and. A stands for applied. And C stands for chemistry. So in other words, we can say that IUPAC means International Union of Pure and Applied Chemistry. बच्चों प्लीज इसको लर्न करें. इट मे बी आस्क्ड इनटू योर एग्जाम्स, सो प्लीज लर्न इट वेल. IUPAC means International Union of IUPAC means International Union of Pure and Applied Chemistry. Please remember. तो बच्चों हमने पढ़ा, किसके बारे में पढ़ा बच्चों? हमने किसके बारे में पढ़ा? नहीं बोलेंगे. We have just studied about the full form of International Union of Pure and Applied Chemistry, and it is the organization, International Union of Pure and Applied Chemistry is the organization that approves the name of the element. बच्चों, इंटरनेशनल यूनियन ऑफ प्योर एंड अप्लाइड केमिस्ट्री is the organization that approves the name of the elements, symbols of the elements. So nowadays, IUPAC approves the name of the elements. Nowadays, International Union of Pure and Applied Chemistry approves the names and symbols of the various elements. चलिए बच्चों, नेक्स्ट टॉपिक पढ़ते हैं. How first and second letter of symbol of an element are written? Explain with the example. अगर if you want to give the letter, if you want to give the symbol to a particular element, how do we give it? So the first letter of the symbol is always written as a capital letter. What is capital letter? It is your uppercase letter. See, this is A. This is what it is known as the capital letter. Or it is uppercase. And this A, this is also A. But this is the small letter. We call it small or we call it lowercase. Please remember. So my dear students, whenever we write the first letter, the first letter is written in uppercase. And the second letter, please remember, the second letter we write in small letters or we write into the lowercase. Once again, my dear students, I'm going to tell it to you once again. How do we write the letters for the symbol of element? The first letter in symbol, the first letter in symbol we write the first letter as a capital letter or we write it in the uppercase. And second letter my dear students, we write small or we write in the lowercase. So this is how, my dear students, we write the symbol for the various elements. Let us understand this with example. Suppose we have hydrogen. So for hydrogen, we just write H, and this H is actually capital. Same way, if we want to write for aluminium, we write A, which is a capital, but we write L. This L is written into the small letter because this L is the second letter. But we do not write AL. We do not write both the capital. Please remember, this L, the second letter, can never be written capital. So please remember, when we write the symbol of aluminium, we write A capital and L small. Same way, when we want to write the symbol of cobalt, we take the first letter C, we take the second letter O, but we do not write, we write the first letter, the C we write, capital. So C has to be written capital, but this O must be written small. Because first letter we write capital, second letter we write small. So this first CO, in CO the first letter should be written capital but the second letter should be written in small. We cannot write both of them capital. So to represent the symbol of cobalt, we cannot use capital C and capital O, but we will use capital C and small o. So this is the correct symbol for cobalt. This is the correct symbol for aluminium. I would like to revise it once again, my dear students, that while writing the symbol of an element, the first letter is written capital, whereas the second letter is written small. Or the first letter is written in uppercase, whereas the second letter is written in lowercase. Second point. Symbol of some elements are formed from the first letter of the name of the element and the letter appearing later in the name. Later means afterwards. For example, for cobalt, suppose if we think about cobalt, we have taken both the letter which are first and then we have given the symbol CO. If we think about even aluminium, we have taken both the letters which are first and second as the symbol. But sometimes what happens, we do not take the first two letters. For example, if we think of chlorine, my dear students, when we think of chlorine, we take first letter C and then the third letter L. Same way as a symbol for chlorine. Remember, the second letter should be written lowercase and the first letter should be written uppercase. Same way when we look at the zinc, you can say that the first letter we take Z and then the third letter N is taken in the symbol. So sometimes it is not necessary that the first two letters are taken as a symbol, but we can use the any other letter which falls afterward the first letter. Some names of the elements are taken from their Latin, Greek or German names. Some symbols of the elements are taken from their Latin, Greek or German names. For example, we have an element called iron. Actually, iron starts with I. But the symbol for iron, but the